Today's lesson is on rotations in the transformations unit. What is a rotation? A rotation is when an object moves around the origin. Or sometimes a point. So think about a clock. If I tell you a clock moves around the origin clockwise, it means that the hands in the clock, this is the origin right here, it moves around that, so the hands are going clockwise. Counterclockwise means that these hands are going the other way, so they move around to the right. There are 360 degrees in a circle. When we rotate clockwise or counterclockwise, the two rotations should always add up to 360. What I mean by that is if I were to give you this image here in number 1, it says what rotation will take P to P prime. So here, P to P prime, we are rotating this line clockwise. And I tell you that it's 75 degrees. But if we went the other way, because you could have gone this way, how many degrees are left in that? So you would do 360, take away 75, and you're going to be left with 285. So if you were to rotate P to P prime going counterclockwise, it would be 285 degrees. Same thing here. We rotated point P to P prime clockwise. Here it was 180, and you know that because every straight line is 180 degrees. If you were to rotate the other way, it'd still be 180. That's 360 minus 180. In problem number 3, you rotate P to P prime, so be careful, you have to pay attention to detail because there is that prime symbol. Okay, so you moved P from P prime, but you are rotating this one counterclockwise. So 40 would go into counterclockwise. If you were to rotate clockwise, you would have 320 degrees. So which one is the rotation? A is a reflection, B has been rotated, and C is also a reflection. In this one, A is a translation, B is a reflection, C is a rotation, meaning it has moved its orientation. Here are rules of rotation. You need to follow these in order to get the new coordinates of your shape. So here I have a triangle tri. What we want to do is we want to rotate it 90 degrees clockwise, which means that the translation would be y negative x. So if I tell you that the ordered pair of t is negative 7, 1, in order to find its new location, this is x, this is y. You have to flip the order and change the symbol of x. This means whatever it is, it's opposite. So since x is actually negative, it's now going to be positive. So you flip the order, y, x, and we changed the symbol in front of x. R is 8, negative 8, 8. So again, you flip the symbol and flip the order and change the symbol. So this is just positive 8, 8. For y, y is negative 3, 5. You change the order and flip the symbol, so that negative 3 has now become positive. To plot these points, you plot 1, 7, that's t prime, 8, 8, that's r prime, and 5, 3, that's y prime. Connect your dots. And if you notice, the congruency has stayed the same, so it is there. And then the orientation is the only thing that has changed. Okay, so let's try the next one. Just so you know, tri is the same triangle, so we're going to have the same points, negative 7, 1, negative 8, 8, and negative 3, 5. The directions say if you rotate 90 degrees counterclockwise, you change the order, but now y has the opposite symbol. So you still change the order. X stays the same. The only one you're going to change is Y. So you would change the order and the symbol of Y. So since it's positive in the original, it's now negative, and 7 stays the same. Same thing here. You have -8, -8. Y is what we're changing, so that's -5, -3 because X stays the same. -1, -7 is T prime. -8, -8 is R prime. And -5, -3 is Y prime. Connect your dots, and you just rotated this back 90 degrees. The last one is going to be rotated 180 degrees clockwise, so that translation is where X and Y stay the same, but now they're both opposite. So if it's negative, it's now positive. If it's positive, it's now negative. And again, our ordered pairs are the exact same. So you just change the sign of every ordered pair. And you have your new coordinates. So for T, it's 7, -1, T prime. R is 8, -8. And Y is 3, -5. Connect your points, and it was rotated 180 degrees. That was rotating around the origin because you were using 0, 0 as your focal point. If we rotate around a point, the image rules change slightly. So what that means is that you're not rotating it from one quadrant to another or around 0. You're actually going to rotate it around that point. So Thor is a quadrilateral, and it has ordered pairs of -7, 1, -7, 8, -5, 8, and -5, 1. Our focal point is point R. So this is the point that we are going to rotate our shape 90 degrees. So since it's a vertical shape, 90 degrees is going to make this shape go sideways. So it's going to fall over on its side. So this one, all we're going to do is just count. So we count, if R is our focal point, R does not change. It isn't going to move anywhere. But let's count. How many units is T from R? So it's 1, 2. And since we know that that line went from horizontal, it's now going to be vertical. We're going to go up 2. So that's going to be T prime. And that's new ordered pair is -5, 3. Then we have to count how many units is H from T. So 1, 2, 3, 4, 5, 6, 7. So from T prime, we're going to count 7 and put a point, and that's H prime. And that ordered pair is 2, 3. And then the last one is how many units is H from O. So 1, 2, down 2. That's O prime. And that new ordered pair is 2, 1. If you connect the dots, notice how you have now rotated Thor around R. So that focal point is where it is rotated. So if you put your finger on that point, you have to rotate the shape on there. It cannot move from that point. So I hope this helped. Good luck on your homework, and I'll see you tomorrow.